The AMPERES program consists of a few major parts: the menu and toolbars on top, the model and graph windows in the middle, the message area, the command line, and the status bar on the bottom, and model tree and search on the left. To perform a simulation using AMPERES, you must first construct a geometric model of the physical system. This can be done using the built-in geometric modeler, or by importing geometry built using commercial CAD packages. We will model an E-core actuator. To demonstrate the basic setup and analysis features of AMPERES, a step file is imported. You can see geometry summary information in the message area. The units are set up from the model tree, or from Utilities menu on top. Geometry objects are set up for easy labeling and selection. This dialog can be opened using the toolbar or the model tree. Clicking the Create button 3 times will create 3 generic objects with random colors, no assigned geometry, and sequential names of Object 1, Object 2, etc. Object names can be renamed as armature, coil, and core. Check the selection type is set to volume. Select the Add Volume button to assign volumes in the model to the objects. Open the material table from the physics menu, select copper, and assign it to the coil, which will be highlighted in green, and then mouse's right-click to end the selection. Similarly, 1010 steel is assigned to core and armature. Save your model. To assign volume current to the coil, select Add Current Source from the Physics menu. Set the selection switch to volume. Verify Active Radial button is set to on. Set the value type to volume total. Check only the static box and enter 3000 amperes. Click the plus button on bottom to add volume to the current values. The mouse is positioned over the coil volume and clicked. When the object appears green, mouse's right-click to end the selection. AMPERES prompts you to select the input surface for current. Surface is selected and current is assigned to connected volumes of the coil. Now you can notice the IDs of the 6 volumes of the coil assigned with the current. Also, this current source was given a default name, Current Source 1, and color blue. If you want, you may change the name and the color allotted by the program. Click on the OK button of the Current Source dialog box. Note that from Physics Applied in Model Tree, when the current source of a region is clicked, that volume will highlight orange in the model. You can edit it by right-clicking on the current sources. The model is now ready to solve. Next, outputs are set up from Define Output box under the Solution menu. Click the Add Plot button at bottom to open the Plot Properties dialog box. Select the 2D Contours tab. Set the field quantity to be Field and location to On Plane. Type -3, 0.256 on command line and press Enter key. Type -XYZ on the command line and press the Enter key. Type XY0 on the command line and press the Enter key.
The interface will return to showing the Define Output dialog, but with one defined plot. Now B field arrows are defined on the same plane around the model using the Arrows tab. Next, set up a field probe from the Measurements button on the Define Output dialog. B field is selected as the field quantity, and XY coordinates are set up. Click on the Add Measurement button to set up force volume measurement on core and coil objects. One more measurement is defined by clicking the Add button and selecting the armature object. Right-click to end the command. Similarly, flux linkage volume loop is also defined on coil object from Measurement Editor. Now all the outputs are defined. Save the model. From the Solution menu, select Run Solver. When the solver is finished, the Output Manager box will appear. Presentation of the plots can be customized by selecting the properties of the plots in Output Manager box.
We can improve the solution with local refinement. There are many ways to accomplish this. For example, if you would like to improve the whole solution then refine solution is the best method. If you are interested in a local area, tell Amperes to put more weight on the solution quality in this area. This sample session has introduced basic techniques that you can use to perform Amperes simulations when beginning with a CAD model.